Hello Finxters! Today I want to talk about a common problem that Python programmers often face, which is the cleaning or extraction of information enclosed in a string. And a common search that you'll find on Google, or a question you'll find on sites such as Stack Overflow, is someone asking you how to extract numbers or digits from a string. And while there's a number of ways this can be done, today I want to focus in on a small but powerful module that forms part of Python called regular expressions. This tutorial won't make us experts, but it will give us the tools to solve that particular problem of extracting numbers from a string for further use. So some of the topics we'll cover in this video. We'll talk about where and why you would use regular expressions and some of the theory behind them, and the basics on how to create a very simple search pattern for yourself. We'll give you some special characters to better target your search, and we'll then create some of our own custom patterns. And then finally, we'll create some links to further your study if you wish to do a deeper dive into the topic. So, why regular expressions? So they were developed in the 50s by a mathematician for use in theoretical computer science, and they're now widely used in programming languages and text editors. They used to either find and extract, or find and replace text, and they can use both literal and meta or special characters to search, and we'll talk about that in a minute. It's accurate, reasonably fast depending on your usage, and it can return the index locations in a string, and it will return the actual matches found in a string. So it's an incredibly powerful tool, and it's not just related to Python. In fact, it's used by all major programming languages. So where would you use these? I've done some examples here, but really the uses are endless. You could search through the results returned by a web scraper. You can extract email addresses from emails or other text. You can capture age, address or telephone data from an online survey form. I was reading an article the other day about a biologist who was using regular expressions to search special DNA patterns in long DNA sequences, returning geographic coordinates and science reports. The uses really are endless, and it's really only your imagination that stops that. So how do they actually work? So we have two main characters that we use to form a search pattern. One is the literal character, so capital A means capital A, small c means small c. A search for Finxter searches for exactly that pattern in a string. Then there's the meta or special characters, and these are wildcard characters that allow us to have a much broader remit in our search and to target very specific patterns, and we'll do that very shortly when we get into the coding. So I want to talk about 6 useful special characters that I use a lot and which we will use today in our coding. The way they are actually shown is with first a backslash and then a letter. So the backslash lowercase d means that you want to match a decimal digit, so any number from 0 through 9. And a backslash uppercase d is the opposite, any character that's not a decimal digit, so excludes 0 through 9. The lowercase w matches any alphanumeric character, including the underscore, and we'll use that shortly in extracting an email address from some text. And the backslash uppercase w is any non-alphanumeric character, so anything that's not numbers, not letters, and it excludes underscores. Lowercase s matches white space, so space, tab, or new line character, and backslash uppercase s will match any character that's not one of those three, not a space, not a tab, or not a new line character. And let's just talk about the use of backslashes in regular expressions, because we know that Python uses special characters that utilize backslashes. Backslash n is new line, or backslash t is tab. And we also use backslashes to escape characters. So if we need a literal backslash or a literal apostrophe, we use a backslash to escape that character, which tells Python that we want the literal meaning of the symbol, not anything special. Now, of course, regular expressions use backslashes, and that could cause confusion. So I suggest every time you create a pattern, we use the raw string prefix r in front of the pattern, which tells Python that you want the literal interpretation of what's within the speech marks. And you'll see us use this in a code in a minute. So this tells Python to ignore the backslash characters effectively. Right, so let's go across and we'll do a little bit of coding. Now, I've already pasted some text here, which was an email I received from Chris Mayer when I joined his Computer Science Email Academy some time ago. And if you look at the email, you'll see that he has here a Finxter community of 31,190 of 7 ambitious Python coders. So there's a number there that we might extract. There's a email address here, chris@finxter.com, and then we have a physical address. So all things that we might reasonably wish to extract from a text string. So first of all, before we start with regular expressions, we need to import them. So we're going to put in import RE, which is the name of the regular expression module that's used in Python. So having done that, we're now going to start typing in the pattern that we actually want to search for. So let's just call it that. Always start with the RE, and then we're going to do something called compile. And compile is a little like creating a function in regular Python where you compile a pattern and Python will actually cache that, and you can use it multiple times through your code. You don't have to compile in some instances of regular expression. You can just do the compiling on the fly. I suggest we compile each time, and that's what I'm going to be doing today. Then we're going to use the R to show that this is going to be a raw prefix, raw string prefix. Now, we're going to use those backslash D's that we learnt. Lowercase d means decimal digit. So we'll go backslash D. That should return the 31 of the 31,000. There's a comma there, so we'll just do backslash uppercase D, which is anything other than a digit. And then backslash D, and there's our pattern. That pattern now matches that 31,000, 197 that we see in the string. Having created the pattern and compiled the pattern, we then need to give it the command to go and search. And that's very simple. It's re.search, and we can talk more about this a little bit later, some of these commands. We give it the pattern we wish to use, and we give it the email string that we wish it to check. And then finally, of course, we wish to see what's produced. So let's run that and see what we get back. And you'll see down the bottom we have here a match object. Match object span equals 201 to 207, so that's the index location of that pattern in the string. And there's the match, 31,197. Now, that's good, but if we just want the 31,197 returned, we just have to add in one more line of text here, which is the group command. And now, if we run this, there we go. It returns just the 31,197. Now, that's good, but remember that this is still a string. So if you wish to use this in a calculation, you'll need to clean it some more. Now, there's a number of things you can do. You can use some substitution patterns within regular expressions, and we'll talk about those a little later. You can use list comprehension to either take out the comma or to replace it with an underscore, and obviously the int command to change it to an integer. So there's a number of things you need to do from here, but we've managed to extract exactly what we wanted, which was a number from a string. Now, that's all very well, but if we wanted to do a credit card number, for instance, the DDD would get a little bit onerous. So let's just go back and look at a couple of special characters that we can use, which allow us to shorthand this. So here's some special characters. Now if we use a plus symbol after something, let's think of that backslash lowercase d for a decimal character. If we put a plus after that, it tells the search to include one or more repetitions of that character. So we will want one or more decimal numbers from 0 to 9 to be retrieved. The star or the asterisk tells the search to include 0 or more repetitions of the preceding character. For instance, if we wanted to search for 34 and we put a star after it, then it's telling Python that it wants either the 3 or the 4, or the 3 and 2 4s, etc, etc, etc. So it can go on forever with the 4s. The question mark tells the search to limit itself to either 0 or 1 repetition of the preceding character. So once again, 3, 4, question mark, you would either get 3 or you'd get 3, 4, and that's all you'd get. The dot, full stop, period, whichever part of the world you come from, stands in for any character other than a new line character. The pipe is used as an OR indicator, so if we put X pipe Y, it will search for X or Y and return one of them. And then of course we have the square brackets. And the square brackets we'll talk about a little bit later. They are used to create a customized group of characters to form a pattern, and we'll see that very shortly in our coding. So let's just go back to where we were, and let's just try and make that pattern up here just a little less onerous. So we can take out that and put in a plus, and we can take out that and put in a plus. So we've managed to shorten down our search string, and now if we run this, there we are, we get the same return, 31197, but with a more readable and shortened version. Now, sometimes you may want to define your own character class, and the ordinary and special characters may be too broad for the pattern you wish to locate. So we talked about using square bracket notation, and looking at that list that we have up there, that email string, let's say we want to extract the email address that we find in there. Well, what we can do is we can use the square bracket notation. We'll take out this and we'll use open square bracket, and remember the backslash lowercase w was for any alphanumeric character, and a dot was for any character. Then we close bracket, and then we put in a plus. So effectively we're saying any alphanumeric character, any character, as many as you can get. Then we stipulate the @ for an email address, open bracket again, and just repeat that same pattern with the plus symbol, and that's it. So if we run this now through this email text string, I would expect that to go and find any email addresses that are in there. So let's run that and see if it works. And there we have chris@finxter.com. So the square bracket notation is a very handy way of making very clear patterns up and customized patterns for yourself. And there's something else in here. Why don't we try and get this address? Let's see if we can return that address. And this obviously takes a little bit more work, but still we'll use a similar expression, which is the square bracket notations, and we'll just break it down into simple steps. So first of all, we know that the German address convention is street followed by number, comma, space, postcode, followed by city. So we need to actually start building a pattern that will go and find that in a text string and bring it back. So I'm going to open with a square bracket, and I'm going to ask RE to look for any letter, capital letter, at the beginning of the text. So for instance, we're looking for a capital S in this instance, and then I want that capital letter to be followed by any lowercase letter. And of course, we use the plus symbol because there's more than one lowercase letter that we want returned. Of course, there's a space that we need to consider, and then we open another square bracket, and we're actually looking for the street number. So we already know the \d, let's use the \d, but there's another expression that we can use here. We don't know if it's 21, 61, 324, so you can use curly bracket, and we'll ask it to look for anything from 2 to 4 digits. And then we want to open another square bracket, because now we're going to go and look for the postcode. But first of all, we need to include the comma that will be after the street number. We need to include a white space. We need to include decimal digit, close bracket, and then a plus because we want a number of decimals. Then we're looking for the city, so we want \space, of course, because of the space between the postcode and city, \W, close bracket, plus, and that should be a pattern that will extract from us the German convention of street, number, postcode, city. So let's run that and see what gets returned. And there we have it down the bottom. I won't attempt to pronounce it, my German's not that good, but there we've managed to extract from a text string a useful piece of information using regular expressions. Now we've used compile, we've used search, we've used match and group, but there are a lot of modules within RE that you can use. Let's have a look at a couple, just so that you understand what they actually look like. So these are the frequently used modules. Compile, you've met. It's simply re.compile pattern, and you saw us use that. Creates regular expressions object which Python caches for multiple uses. You saw us use search, and we just need to pass search the pattern and the string we wish to search, and it will return the first match as a match object, which is worth remembering, because the next one, find all, has the same layout except it checks the pattern and returns a list of all matches. So it depends how specific you want to get. The re.match checks for the pattern at the beginning of a string and returns a match object. re.split, this is often used, splits a string where the pattern matches and returns a list of strings, and you may wish to break a string up at white spaces or new lines. So you'd create a pattern that did that and then return a whole list of strings that's been created from there. And this last one is the one we spoke about, which is the substitute, re.sub, where you put in the pattern you're looking for, and then you look in what you actually wish to replace that pattern with before returning a new string. As I said, many more modules that you can call on, but this is probably a list of the most frequently used ones, certainly the ones that I use. Now, I highly recommend, if you wish to know more about the intricacies of regular expressions, that you go to blog.finxter.com, and there's a marvellous, very long blog there that runs you through the Python regex. Now let's talk about that subject, regex. It's a shorthand notation that people use for regular expressions, but it also is a third-party module that uses an API which taps into the standard Python RE module that we've been using, but it also adds increased functionality. And if you wish to explore regex, you can find it at the pypy.org site. So, in summary, our task today was to extract digits from a string, which we accomplished. We learned about the Python RE module and importing that to create a pattern of characters to extract from a string. We learned some standard and special characters to create our own customized patterns, and we learned commands to accept our pattern and return the location, match, and string we're seeking. Thank you very much for listening today. I really hope that was helpful, and I look forward to talking to you in the next tutorial. Thank you and goodbye.